Yeah, so I'm Henry. I'm doing currently a PhD in the scope of a Copenhagen Bioscience PhD program. I did my master's in Berlin, where I studied statistics, and between the three Berlin universities, then I was 1 year in a trainee. And as I did a master's thesis in a small project at Charité, I was basically already interested in these biomedical applications and bioscience applications, and that's why I decided to do a PhD in a very well and nice organized program here in Copenhagen. And yeah, I have 3 more years to go. And Free asked me when I prepared a Matplotlib workshop recently, which is also now part of this repository. Yeah, she just asked me if I would be up for giving this introduction. And so my idea would be to give some overview over the tools in data science and what Python is to me and to maybe other people, intermixed with some experiences. So the link for this introduction and also the link to more of the notebooks are in the session chat. If you're interested in taking part in the entire course, so basically the notebooks to follow, we still have to update it and prepare it in the sessions, but it will be from next Friday on, probably some Friday afternoon sessions. Yeah, write me on Slack, on Correl8, or write me here a private message in Hopin with your email, and then I can add you. Okay. So if you want to save this notebook persistently because you like to play around, you have to, click on the link I provided, which is also linked here, which will lead you to, okay, let's do this, which will lead you to Colab. It's basically only referencing a URL on GitHub and then just loading it interactively, but it won't be present all the time. And yeah, you can just copy it to your drive, and then you have a persistent copy of it, which is also, intermediate results are just saved. Yeah. So these are these ways, and you also for navigation. If the notebooks, some of them are longer, you can easily navigate on the left side. This is all I want to talk about setting up basically your installation for now. To get started, I think Colab is totally fine, and you've got a working installation, but most of the packages you will need for now. And yeah, if you have some, maybe we can just talk about this in one of these open data science sessions. I'm also not an expert in every detail of setting it up, but there's then Anaconda you might heard of, or Python installers for various systems, but it depends always a bit on the machine you're working on. And there are so many tutorials on this that I skip it for now and just refer to Colab. And I'm also planning to give more of these notebooks just in Colab, so we don't have to, in these first iterations, deal too much about with installations. Okay. So what is Python? And I listed here some things. For me, obviously, it's a programming language, which gives you some syntax and some ideas how to do things in a certain way. And there are many programming languages, and depending on how familiar with one or the other you are, you find one more intuitive or the other. But Python is around for 30 years roughly now, and gained popularity in recent years. For me, it's also a community of developers. So who's basically programming Python, and how many people in different fields are applying Python, which I would say is quite extensive. And so far, if I was looking for some functionality I needed, someone else probably started at least with some kind of package for it, and it's really extensive. It's also a community of conferences. So there's PyData conferences, there's PyData meetups, there's the JupyterCon, similar to CorrelCon naming. There's SciPy conferences, and there's also a whole community around NumPy. which is then part of the SciPy conferences. And most of all, it's really a high-level language where you can interact with many tools. And I would try to give a few examples. But basically, maybe you learn Python in first introductory course, but afterwards you will never use too many low-level features of this language. Okay. Please, questions again. Just you can on your own participate in share, or I think I forgot what it says, but participate in the session or just write in the chat. And it's nice to look at faces to see if something is clear or not, but don't feel pressured to do it. Okay, so an attempt for a great and beautiful language. Guido van Rossum is, oh, I spelled him wrong. Guido van Rossum is basically the founder who started this project, a Dutch computer scientist living in the US and mainly known for his work at Dropbox, mainly known for his work for Python, but worked at Dropbox. And yeah, I tried to find some quotes, and I mean, the one which is maybe, that's one of the big discussion points, which I agree, is to make it accessible to be read and to understand the logic of to transport what is going on and what should happen. So, and he says it's about communicating ideas, and it's to be understood by other programmers and not so much about computers. So that's one of the ideas, and maybe we'll also see what we can do. Have a look at this. So it should be readable, consistent, and easy to learn for now. There are Easter eggs in this language, and one of these core principles you can just read is, again, basically like a poem to reference the ideas and the guiding principles. And I would again highlight that readability counts. So let's say we want this. And then, of course, you can also look for more Easter eggs. Just as a advertisement, you can then also, if we started looking at what is happening, so what is, I mean, if you, as Florian, has some background in R, it's maybe easier to grasp why this poem, what this poem does and what it is. I mean, poem exclamation marks. And if you're not, we would have to talk a bit about what is a reference, what is the actual object, and this is then also most of the times covered in some of these basic courses. But I would say mostly you will figure this out after some time, and it's more important if you really use the data structures of Python and you really want to develop things for your own. And as I will show again, most of us will never do this. We will just use Python as a high-level language to use some applications which are provided for us, and we don't deal too much about, I mean, if we follow the tutorials, nothing will go wrong normally. But here, we import this. This is, we don't know. I mean, for you, you don't know, but so this, if you import something, it's called a module, which is in principle only a Python file, and then love is assigned as well this, and then it says that this is love in the sense of, okay, what are we referencing here? So I will skip this and just show you the poem, how it's working. But it would be a nice introduction for the is operator, which is giving you the identity of an reference or of an object. So love and this point to the same object behind the scenes, which is in this case only a Python file, which is for now very high level. But yeah, so, and for Florian, as I see him as the only one, I mean, I started with R before I really started with Python, but I mean, it was kind of simultaneously, but I think I skipped in R this step of really understanding the basic programming principles, which I first grasped in Python. And from there on, for me, Python was always more logical. But maybe, if you want to comment later, the same kind of ideas, what is a reference, what is an object, is also very well defined in R. And so it really depends on what you like. But here, I mean, this is the is operator is looking at object identities. Yeah. You can try to wrap your hand around why what is going on behind the scene, or what is it doing. But I think this is sticking around because you can basically read it as a sentence. And if you know Python, again, readability counts, it should be fairly easy and straightforward to read. That said, and I don't want to elaborate more on this. Okay, so it's a programming language. It has some principles, and it's mainly about readability. Now we jump a bit into something which I would love to have learned earlier. So you sometimes, I mean, if you start now, you will learn all the basic syntax features and manipulations. But I would say, just if you're very new to Python from another language or totally new to programming, there's something called a data model. So everything is in Python is an object, and these objects know how to relate with each other by more or less so-called magic functions. So everything is an object, and now we look at an example of one, which is here, just the division. So 12 divided by 4 is 3. It's a float, as you can see, because it's a point. And what is done behind the scenes, I just want to show once, but just to be, so you know it, is this syntax is invoking a method, which is a function of an object. So a method of this A is some kind of object which has certain behavior. It has an implemented magic method called true divide, and you get the same result. So in Python, syntax is basically translated to these kind of method or function calls behind the scenes. So a method is a function which is bounded to an instance, which is called on this instance of an object. Many words, I mean, it's a high-level introduction, but if you have seen this, you might wonder, okay, why does this work? Yeah. And again, and this is then maybe a bit sketchy, so you can also redefine, no, you can define for a class or something you program and you provide to us as a user, you can define what this syntax should mean. So it's a bit, hopefully, I mean, you can write me if this is understandable or not, but basically what the dash means as an operation is defined by the method true divide. And more you don't need to know for now, but that's it. So, and if you want to do path manipulations, sometimes it's quite handy to use the path lib, where this dash operator is meant, if you know bash, how to basically build path. And this leads to all sorts of nice to write things. Maybe it's also confusing, but it's around. So if you see this, you could be confused, why should this work? But that's how the Python data model is implemented. And now, just if this can be interactive, so I only have one who I can ask, but okay, so relating to this, how would you think you call the length of an object? So if this whatever A has a length, we assume this, can you think about translating it to this A? I can't hear you yet. Are you muted?
Now?
Yes.
Yeah, okay. So, sorry, I'm not sure if I understand your question correctly. So you defined A, and A is an object.
You don't know. I mean, I haven't introduced it,
I don't
but
know.
it has a length method.
Okay. Yeah.
Or you can perform length on it. And could you guess now how you would translate this as a method call on this function, on this object?
Okay. So yeah, I would call the object, so A dot, and then I would guess the underlying function, which you said, true divide.
Yeah, I mean, true divide is, I don't know if it exists for lists here, but I mean, I wanted to go, in this case, there is nothing you have to specify. You call it just on itself, and then it would be, okay, this was not true.
Okay.
Yeah, I know why. I renamed everything. So. I executed everything before, just to don't have to re-execute. Now, yes. So this list has a length of 4. And again, this is magic methods. So just to be sure, if you ever see syntax which is behaving differently between two objects and you don't know why, you can guess now it has to do something with the implementation of the object, and you can just try to look it up. So it's all magic. It's all methods attached to objects. So it's really, in this sense, everything is performed on objects. Okay. Then, I mean, Python in a work environment for me, for example, I used clients to use other programs, and PySpark is, for example, quite known, maybe. So if we open this one, I mean, okay, it's a bit tiny on the screen. So Apache Spark is written in Scala, so another programming language, but you can use it from Python because there are many interfaces to use different programs from Python. And as this is quite general true, I mean, I found that for now I have never missed a client in Python if I actually want to use a different tool. Just saying, this is also true for R. I mean, R also has a PySpark client, but if I'm not mistaken, I mean, at least some clients are not available in R, where they are available in Python. And I don't want to say, but I mean, I think TensorFlow and PyTorch don't have an interface yet for R. Also, I mean, underlying both of these libraries is some C library, which is doing most of the work, or whatever kind of other programming language, and you could probably also define an interface, but it's not available as far as I know. But in the newest RStudio, I've seen you can run Python files, so I mean, you could go crazy and do all kinds of things, but it's maybe not the best setup. Otherwise, yeah, Python has many tools. Most of the tools are not like in the underlying function, probably not written in Python, but in some other language, which is then just available and made available to you by here? Yes. Okay, so now it's from PySpark, but let's further talk about data science applications. I don't know if you've heard, but we will look at the small pandas example in a second. So pandas and NumPy are libraries which have you doing data manipulations. They are also in the backend. I mean, pandas uses NumPy, and NumPy is an interface for different C libraries which are around to hold data and perform quick operations with some principles, which we don't care now, so, which allow it to be quite fast. And these libraries, I would say, you don't, I mean, maybe you learn Python and you learn some of the principles, maybe high level, ideas about Python, but in the aftermath on your daily work, probably, you will just learn some application programming interfaces, so APIs of pandas and NumPy to do some computations. And it would be, I mean, loosely defined is to know how you use pandas and NumPy. And this does not specifically mean that you know a lot of Python in the core Python world, but of course, I mean, what an object is, what a method is, and some of these underlying principles of how is the language structured lets you just navigate into this in these interfaces. But basically, you delegate all the hard work of programming logic to some libraries, and you just use their interface, and the interface describes what you can expect to happen when you ask the application to perform certain things using their API. And this is also true for Matplotlib. Matplotlib itself depends on which machine you're running, has in the backend some kind of plotting functionality, but Matplotlib itself provides the API to use these and define how to plot all sorts of things. And probably most of you as well, if they start, won't use Matplotlib itself, but rather go to Seaborn and or Pandas, which both are able to call Matplotlib in to perform certain operations on data frames, on Pandas data frames. So Pandas is very central, and to get started and do some kind of data visualization and get an idea about data, just collecting it and manipulating it. This is, you rather look at tutorials of Pandas and read on Pandas. If you have set up your problem and you want to go to learn something from your data, machine learning here loosely defined as the science of learning from data, then you can try to use scikit-learn, which again has an API, which again is helpful to know a bit about, to just orientate oneself in it. And in this course, I will be giving with others. It will be at the end. You then have a fair amount of hopefully handling capabilities of data, and then you can also set up your learning tasks and think about how to go about this. TensorFlow and PyTorch are for these deep learning applications, the frameworks where you just relate to. But a very simple forward neural network you can also train and scikit-learn easily. But I mean, no one does it, so everyone uses then TensorFlow, PyTorch. Yes, and I want to say mainly you learn certain APIs of applications provided in a Python syntax. That's it. And then after a bit of Python, I mean, don't spend too much time in Python, but rather dig into the actual applications. So I prepared a small Pandas example, and again, depending on what you want to do, we can also you can also try to play around with it. But so there's a European Center for Disease Prevention and Control, I found out, and they provide testing data and the daily numbers worldwide of COVID patients. So now we look a bit at what's Pandas basically. So Pandas is now somewhere on this Colab environment, and it's available. It's a software which was installed and which you have available for now. And we say we import the package and we give it a name, which is PD. This is the default you will see everywhere. And if you then look what is PD, it says it's a module called Pandas, and it's imported basically from a file init py. And we don't talk about packaging, but there's a folder Pandas, and in this folder Pandas, you can basically find all the things you can see in the documentation. In this Colab notebook, if you need help and you want to see, okay, now I've seen Pandas is a module, well, okay, you can click, you can just add a question mark at the end, which is in this notebook, and I will try to also highlight this, then calls the module, the documentation of this module, which is just implemented in the file itself. We can have a look in a second, which says pandas, powerful data analysis and manipulation library for Python, and yeah, it's providing flexible and expressive data structures, designed basically to make it at least very easy to work with Excel-like data, so spreadsheet data, and do all kinds of manipulations straight away. And then you could read a bit about it without going out of your Colab environment and going actually to the documentation. Okay. So now we just want to look at the daily use cases. And I mean, I've done daily cases, I said no. I went to this link. Then I see, okay, there's an Excel table. And you can also download the CSV. And I just did right click and copy link address. And then you can just copy paste it here. Yeah. I take it out again. I copy it, I assign it to a variable, and we talk about this if we have time in the second notebook. We really just go through assignments. And yeah, maybe less confusing, we could also do this. We could just paste it as a string in the pandas. Now, yeah, PD was the pandas library. It has a function which helps you just import data, and it can read from file or as here directly from a URL, and it knows how to treat this URL and get the data. And then I had to I played around with some specifications just to get then a view of the daily data. And again, no, not again. And here I use pandas to read a CSV, which returns me an object in this library. So mainly in libraries, and now in pandas, you have some kind of high-level utility functions which help you create objects, or you can just and then you have the basic objects themselves in the pandas. Let's go quickly, maybe look at pandas. I linked them all here. In this pandas tutorial, 10 minutes into pandas, you will see that there are data structures, so that are the objects you can basically get, and then there's utility around it. And the big two structures are a series and the data frame. A series is basically one column with an index, and a data frame is several columns, again with an index. And you can just read through these tutorials, and they give some more or less convincing examples, but it's all self-explanatory. And yeah, you can, I mean, you don't have to load data or something. You know, it's all in the documentation. Okay, so we loaded using a help function, a utility function, a CSV file directly from an URL. We passed the dates if there were some, and yeah, we inferred time format. And then we can just see here that now the index is still just a numerical index, so we didn't set an index. We could use the date as an index, for example. If you try to play around with it, you will probably, I mean, just I tell you that you can do it, and you could now try to work with the data once your a bit further in your journey to Python, or pandas in this case. Okay, here I try to pass the dates further, but I skip because I just want to load the second weekly testing cases. So there's some discussion about testing and what kind of positive testing rate can give you as a hint of how severe the situation is, as a different source of information, which is fairly recent. And here you can also just go again to the website, find the CSV, load the data. Now we look at the last 5 entries, so the tail of this data set, and see that it's the UK. But again, we used the pandas library, the utility function read CSV, and then we got back the data frame now. So I think it should work. Read it now. So although the question mark on an already defined instance object will still give you the type and then some further information, but it says 2-dimensional, size mutable, potentially heterogeneous tabular data. So you can basically, it says you can store all kinds of things together in one data frame. But the type, again, there are objects, there are functions. The type of this variable is a data frame. And many people, but this is the same in R. I mean, it's dynamically, so you cannot see from the name itself what kind of type it is, and you can also reassign names and references as you like all the time. So if we've seen this before now, I am somewhere below. I also defined something which was called A, and then my length was not 4, but I think 100 million or something. We'll see this example again in a second. Okay. So then we can try to say, okay, in this data frame object, we look at the column country. We want to know if it's, we want to have a NS and double equal signs means equals to France. So in this instance, in the column country, where is the column equal to France? Then this is a long list of true and false assignments per row. And then you can call the location method on the data frame with this mask to say, give me yes or no for the location according to this long mask of is it equal to France or not, the entries, and the entries are then the weekly numbers for France, for example. And you could do it for the other countries you're interested in. Yeah, basic data manipulation.
Yeah, short question in this regard, maybe. So how would you now query for multiple countries? So in R, you would use the combine operator and combine multiple countries like France and the UK. And how would you do it here?
Okay, good. Yeah, live programming. Yeah, challenging. No, okay, so we could do, okay. So we cannot, I'm in a presentation mode now, so I have to make some space, but so you could do mask 1. And now we could use Germany. No, yeah. Tab completion gives you a view of what kind of names you have. So if you press tab, also in the Colab notebook, if you press tab, you get certain suggestions. Then we try now just to look at the country. Oh. Yeah, so, and then this is basically only this column now selected. And I mean, brute force approach would be to say, Germany. And a long list of false and not. we assign this to mask 2. Now, just to not get being confused, I use mask 1 and mask 2. Now I have to play around because I think if this works on directly or if you have to loop over it. No. So and it's the ampersand symbol, which should give you the combination. But I mean, this is not how I would do it. Yeah? I mean, this is shown the brute force support. Now you have a mask 2, and we just assign it. Now, hopefully, we see both. Because it's not and, it's or. It's, okay. Yeah, you have now France and Germany in one. And and I think, so I would actually do it as, again, I go to this column. And we do it for now like this. And then call this in, I think. Oh, I don't know, maybe, what the functionality is. Oh, no, I mask this. I don't want to recompute it this all the time. Whether elements in series are contained in values. Then I would do values has to be parameters, values, has to be a sequence of values to test. Set or list like. Okay, I've never tried set, so now you see a set for the first time, which would be France. And Germany. Sorry. Okay, this does not go away. I thought this should work, but the object is not scriptable. Ugh. Okay, so I go back to my initial one because I just didn't see that I had the wrong parentheses. So there are, now we see both, no? The open ones, normal parentheses, and the squared brackets. So the brackets, sorry, that's what we call. And the brackets, again, mean from type to type different things, but they're also only calling methods if you apply them on an object. But here we try to call the method is in on the series. So the country is one column, so it's a series is in with this 2 arguments. How it should work. And yeah, if you look back, then you get the same result. The mask is again passed, and this is how I would do it. And as it's said, you can also just pass a list, so whatever you prefer. But a set is nice in the sense of if it's very long and you add it iteratively, then a set always only contains one value. So you can pass it 3 or 4 times. The values won't be duplicated in this list. And I don't know if this will lead to big troubles if you duplicate it, but yeah, we can try out. But in the end, this is how I would personally do this kind of masking and selecting. Good, but I guess this is one of the questions you had already once or twice. Yeah. And there's another method when you like SQL style writing, which Conrad introduced to me. You can use also a query method. So it's also very expressive if you want to say so, that, okay, the column country is equal to the United Kingdom. And here, I think you can also just do a list or some sort of combination. But again, I mean, I'm using the first two things, but there's, in this case, different methods leading to the same result. So no, this was just data selection, and then you can look for these countries. Good. And you can also, as I tried to mention before, use pandas to directly create plots using matplotlib. And this we will call the method plot, and read the description of this method plot, and it says makes plots of series or data frames, uses the backend specified. Okay, that's not important, but you provide some data and then some labels which you want to plot. There are different kinds of plots which you can also try to create directly. They are all from matplotlib. The default is a line plot, which we also only use. And yeah, then there are more arguments which you would understand if you just follow any kind of matplotlib tutorial. And I try to give a high-level overview in the open data meetup of Coral 8 2 or 3 weeks ago, which would be on YouTube, I think. Yeah. Then there's this in action. So we set an index year week. So the index is the default plotted on the x-axis. So we set the index of a column to this data frame, and then we just call the plot method on the positivity rate, and the rotation 90 just means that I mean, you can also use 45, that the labels on the bottom are rotated. So yeah, if I would not put it, you cannot read it. That's why I had to edit. Good. So now I showed you, okay, how to plot for France, which is a fairly, I mean, it's only one country, and it's a positivity rate, but there's and it has the label positivity rate. What to do if you want to combine several countries, then you normally would go on setting the index on 2 columns. So yeah, I mean, oh, this is important. So we use a data frame, the whole data frame. We set the year and the week and the country, and then this is a bit ugly, but this is how you can say, give me everything where there's France for the country index. And I don't expect that you really need to follow this and understand it already. I just want to motivate that it's kind of powerful and you can do many things. The slice operator, I think, was introduced because NumPy used it to Python. So it's really an addition because of the data science people need it. And we assign this data to a data frame, this basically view of our weekly testing cases of all countries. And then we can look at it. So we have now an index week and then all the countries as a second index. This is how you would access only for France all the cases again in this data frame. And just to say, I mean, because this is also sometimes, pandas gives you the interface. You don't really need to think about what is happening on the underlying data. is it actually manipulated, or is it only computed again and again and returned to you to view? So in this case, the original data frame should be still the same, because I never called, I never reassigned the actual data frame or said do it persistently. So the original data is still there, and this data frame, whatever it is, gives you a view, and Pandas is clever enough in the underlying structure of the program not to duplicate the data too many times and blow up your memory too fast. So normally you don't have to really deal about it and to think about it. Yeah, but you could force Pandas, of course, to copy everything within you and get this memory quickly filled up, but we don't do this here. And I mean, this is not big data frame anyways. Okay, so now we called the plot method directly. If you don't specify further arguments, and then okay, I'm so bold to try this because I didn't before. So then you would look at the plot method, and then there are different arguments around, and the default one has no fixed size, and it would, I mean, it's information overload. You could then just specify the fixed size if you want it bigger or smaller. So you can see the different things happening here. I mean, this is now wider, and of course it's still very messy, but probably you would only select some of the countries so you can get a better overview. This was basically my basic data science motivation. With Pandas, you can also use already use matplotlib directly from Pandas itself. If you look at Seaborn, then you can also use all kinds of data manipulations and summaries, create summary statistic views of your data frame. And yeah, I mean, I would say for many people, this can be a better option. I mean, R has the same, no? I mean, I'm not saying that you can only do it in Python, but it's a nice start not to use Excel. And the nice thing is you can run this from start to end. And as we specified URLs here, you can automate your report also on a weekly basis without, if no breaking changes are, but I mean, more or less, you will have it within a new short time. And I'm not sure that you know how to program Excel to do the same in, what is it, VBA or whatever. So, I mean, it's just very nice. This was my motivational part of this talk. Just to mention it, there's also web programming. If you want to use Django, okay, which is a big framework, there are, I mean, Django gives you, I don't know which JavaScript library it uses in the background actually, because I'm not a web developer. But Django is a platform which at least allows you to build quite big websites. And I linked an article here saying what are actually Django-based websites. And for example, the Instagram website itself is built in Django. I mean, not the app, but the website in the browser is a Django. Spotify apparently as well. YouTube, I mean, I also don't know this for sure, but I mean, if we trust this article, then this is also a capability. So if you understand basic principles in Python, then you of course still need to probably know a fair bit about websites to really meaningfully use Django, but it's all there. And at least with a basic understanding of the language, you can use it. What I rather do is I use programs from within Python to build dashboards. There is in R the Shiny, where we also have an introduction, I think, at the same time. So I think none of you has seen this. In Python, the most, I think, prominent one is still Dash, which gives you the ability to build nice applications in the web browser first of all, it's all local on your machine, and then it's of course the next step, as you have maybe seen in Freeze Talk yesterday in the evening, to deploy it so that it's scalable. And if you have 100 users, it should work the same as if you have 1,000 users. I mean, this is then the next level, which has nothing directly to do with this application programming, but at least to provide it to someone who wants to run it on his or her own machine, to have an interactive view. This could be an option. I like even more Voila, because it just gives you an interface to notebooks. Basically, it just removes all the code and outputs you a website with the pure outputs of your program. And if it's a fairly simple notebook, you can directly basically have a nice web interaction. I mean, it shows you this here. So you have some code and notebooks, and then you can get back a nice dashboard. It starts the server, then it's in the browser, and then you see basically the same notebook just without this code sets. The same is possible in R. I think it's R Markdown, I think, has the same option, at least for static reports. I guess there will, I mean, otherwise it's R Shiny for interactive things. But yeah, in Python you have Voila, you have Panel, which is comparable. You can also just use for your own programming IPy widgets, which gives you basically control sliders in your notebook to interactively create the data. I mean, this we have just seen in this Voila example. I mean, they use IPython widgets. This is the widget here, to manipulate certain input ranges and to query your data interactively and to create simple dashboards. And Streamlit is another new development in this direction, which is aiming for the the machine learning, deep learning community to basically build interactive for their deep learning models. It was briefly mentioned yesterday in the chapter introduction, chapter calls. Okay, I'm just saying this exists. So if you ever, I mean, if you start programming in Jupyter notebooks, and we have a look at this in a second again, you're basically already good to build a dashboard out of it. For Florian, if you're like RStudio, and I will just open it here, there's something similar which is called Spider. I mean, PyCharm is around. I personally use VS Code, which is an editor, which can also open notebooks and give you an interactive view. So I'm just the project Jupyter. So this should work. Yeah, okay. This project Jupyter, if you've seen it, it's basically Jupyter Lab, and I show both now. I mean, I show my presentation both in Jupyter Lab and the Jupyter Notebook in a second. So it's an interface to program and visualize. And you can use, for example, if you use Spider. Now this is somewhere run on mybinder.org. It's a service where you can also deploy open source small applications, small dashboards, which use public data. So let's say you use the positive rate and you build something, then you could run a Voila instance in a Jupyter, in a mybinder.environment, if you ever are interested in it, and deploy it as a small website, which should scale to as many users as possible, because every user just gets a new small machine on the mybinder server infrastructure, which I think is Google Cloud. Yeah. Yeah, if you start the tour here, just Florian, I mean, you can do this, but this should be fairly similar to what RStudio offers. You have an editor, you have your console, and if you create objects in your console which are running, you get a representation. Yes, come on. File folder, you get a representation of your objects and what they contain. Yeah, okay, I missed this. Where was it? Profiler, find. Okay, yesterday it was the, yeah, variable export. So I was too quick. Okay, yesterday it was showing some examples. Now it's missing. So then you would see values and outputs here, like what you know from R, that you can interactively look at your data if it's, yeah, without calling the methods to look at it. Okay, so this failed, but I mean, Spider is debated. Most people don't like Spider, but I mean, it's most advanced Python programs don't like Spider, but it's a bit, maybe it needs a bit more resources, but RStudio is the same. I mean, if you want to have these interactive features, you need a bit more resources, and it's working very nicely, and you can get along quicker. So now I promised to look. So this is my Jupyter lab, and the presentation itself is this one. And let's look at the second one. So it's, I render it also currently as a presentation. So it's the same basically kernel underlying, and we should see whatever our new introduced masking things here. So what I just did in the other browser is also visible here because it's just loading from the file the current state. And what is saved in this, it's a text document in a JSON format, and yeah, then you can basically use this interactively. Jupyter Lab tries to be an IDE-like. If you look around, you probably also find all sorts of add-ons, which I think, I mean, this is just, again, the table of contents. This is the add-on tab, and you can probably also find a variable viewer. I've never done it, but it probably exists to some extent. And yeah, I mean, you can also just open, I don't know, yeah, a markdown document, so a text file, and then you manipulate it. So it's very easy and straightforward web interface. This would be the first notebook after this session we could do, but time-wise, we're already, I think this is impossible, but I will give you some link to resources. And this presentation, if I go out, is the same. I mean, it's the same basically program running. Jupyter Lab has a notebook view and can also have the classic Jupyter Notebook tree view. And in this tree view, there's a package called Rise, which I can use to create from my notebook, which I conceptually try to order. And at some point, I just go to create the presentation out of it without adding anything additional. And then you can configure it and you can read through Rise. Don't do, I mean, if you want to go to Rise, it's, I mean, it takes time to be really familiar with it. And, but for now, it seems to work a lot better since 2 years ago, I tried it for the first time, or 3 years ago, I don't know. And yeah, then you can just say, okay, what is this? Is this a slide? Is this a sub-slide? Is it a fragment? Should I skip it in my slides? And you can basically natively create your interface. Yes. So now I enter the presentation here. And this is Jupyter Lab and Jupyter Notebook. This is a notebook, as I just shown, and this is using IPython. If you really, I mean, if you maybe see this later, also in these first exercises, some functionalities are only available by IPython. For example, some magic functions in this basically header cells, which is also available in some PyCharm and VS Code, have the possibility to write in a script structure, so not in a notebook, but in a script structure, also these kind of cells. But you get, for example, here the time method, which just times the the execution of this cell. And here you see the second A, which I accidentally still had a memory before I reassigned it to shorter list, if you remember, but okay. Then you get a wall time. How long did it take? You can, I mean, if you make this very large, you can also wait a long time. And it fills up your memory. So, but never use this, please. Yeah, it's just a list of 100 million integers, and you can just then access the single entries of this list. Okay, the same is possible with NumPy, but it's just a lot faster. It should be a lot faster. No, okay, it was not faster. Now, before it was milliseconds, I don't know what's okay. Maybe it's not faster. Good, but at least the operations on this NumPy arrange array should be faster than the pure list object. Now it was faster probably because I re-executed it. So, but, okay, I don't know. So I use NumPy for multiplications. So IPython has a lot more. It's, I mean, it's again a library, and you use basically the interpreter as it is. Free. No, it's I don't know. I have also another appointment later, so I would. I mean, I would be here around discussions, but I would rather be open for questions. So I think 90-minute talks, also high level, is maybe more than enough. But again, and I repeat this for everyone: if you really want to learn Python, just pass me a message, a private message here, or with me, let's say. Write a private message here, or send me over Slack a short notification, or find my email somewhere, and then I can add you to this course we will be teaching now online, or I will try to teach online, as it's not going to happen in person this year. Yeah, so just this, if you want to debug, for example, so you don't know, you want to look at intermediate states after this line is executed, you can call a debugger directly from within Python, and and exit again if you want to try basically to iteratively develop your functions, and you don't want to return something in between or print too many things, and you can just go in and interrupt the execution of the code at a certain point in time. It's very convenient. I mean, there's also this, everything in IPython more or less exists somehow also in pure Python, but it's just optimized for this environment with some kind of more code highlighting or more interactivity. And yeah, if you're in the notebook, then you don't have to use the pure PDB, but you can just use the debugger from IPython to do whatever you want to do. And yeah, if let's yeah, maybe a nice trick here would be, now we make some mistake, and sorry, that I should prepare some empty cells in the next time. Now we have a mistake. You can also, I think, it's called debug. Then it would stop, open the debugger. Here now, okay, this is a bit too nested. I mean, if it's not your real frame, okay, yeah, it's starting the debugger, but in this case, it's somewhere in the execution of IPython library, and yeah, it's not helpful. So if it's a syntax error, you already see the syntax error and you will correct it. But if it's some kind of error which is happening in new functionality, you can just also call debug, and then you also go to the place where you want to debug something. Yeah, don't use this. I just say there's a OSPath library which ships with Python. So some libraries you have to install, some ship with Python. OS directly ships with Python. Pathlib also directly ships with Python, and you can remove extensions. What I try to do here, just by calling certain methods of it. So just for reference. Yeah? How do you remember this in case? And again, most of the times you just use Stack Overflow to find it again. And I thought, okay, I'll try, okay, which kind of example I use now to show the debugger. And then I just created the path lib. I mean, I just had to look it up, and then you find some Stack Overflow posts where you see examples, and that's it. And it's nice that you then also can directly put it into your notebook. If you use some functionality, just put a link where you found it in case you ever want to reference it or need it again. There's this, I mean, if you heard the controversy about the last JupyterCon and Jeremy Howard there, I mean, he says, notebooks are nice, and I haven't looked at the functionality, but this Fast AI, which is a library high level to use PyTorch, they apparently developed a lot of things around notebooks to really program everything in notebooks and align tutorials, documentation, and building websites all out of basically one Python project. So I haven't checked it out, but I mean, notebooks have this advantage that you can document and write code at the same time, and at some later point, just copy it manually to a Python file or not. Which leads me already to where to start from now. And there's one slide now for at least Florian, who's probably has already some experiences with programming due to his exposure to R. And then the official tutorial is a good starting point. Once you're through this, I would read Fluent Python, the new version which comes next year. Maybe you can also read the old version, but I mean, there's a new version at least on this way next year, which is not only the language, but also concepts around programming. It will take you some time to read, but at least then you develop also on the scale of being a real Python programmer and knowing some items. Then you can, of course, there's a free Codecamp intermediate course, the Hitchhiker's Guide to Python I really like, and there are all sorts of introductions. If you're new, I would start with, because it's just online and free, I think it's a DataCamp provided course, but you can learn the basics of the language, go through hello words, variables, lists, and basic operators, string formatting. So all the basically hard basics. Then there's a NumPy and a Bantas basic tutorial. And again, more advanced concepts. I mean, I would say sets are not super advanced, but what a generator is in comparison to a list is kind of interesting to see. And this is a nice reference. You can just pinpoint people, okay, you just maybe redo this tutorial. And if you then read Fluent Python again, then you get to know more about about these underlying concepts. So yes, I can also post it in the session chat. There's a list of references, and apart from that, I think it really, I mean, if you only want to start learning this language and let's see, okay, then you know some of the language features, some of the data structures, how you do some things. But in the next step, once you're done with this, just go to tutorials of the big libraries and work through them. I mean, it's not like you have to do magic or something, but if you do this along with the possibility to maybe ask someone who has a bit more exposure to these concepts, you can learn a lot. And with the time, you will also be able to read documentation. And with the time, hopefully, you will also be able to efficiently Google your way to a solution. And again, I mean, this course, which I try to build with other people, one of my ideas really is to, if you know the basic structure of which objects are there and what kind of functionality is supposed to be around, you will find your way easily then by Googling. for the concrete solution, because you can know, you can relate the answers you see to basically the library you're using. And it's not like all magic, copy pasting some lines and it works, but you have no good feeling about why it works. Yes, with this, we're at the end. And I mean, Florian asked to see how do you select more than one item. Very nice. I'm glad that it worked. And yes, if you have questions, please join the session or write in the chat. Otherwise, I'm at the end and I won't start now another tutorial.
Thank you very much from my behalf, and I think also from this silent other people so far. So it was a really great introduction, and I really appreciate all the resources you also added at the end, and I already clicked a few of them, and there's much stuff to
yes,
take
but
down
there's
the
a lot of
rabbit hole.
resources, and I have the bad tendency to spend too much time actually on selecting the resources. I mean, you see the big websites, whatever your first impression, if you like, it's rather just do one. I mean, the basic Python concepts are probably taught in many places quite sufficiently and quite well. Of course, if you can have someone to ask questions in between, it's nice, but yeah. To get started, that's the point. You can start anywhere.
Yeah. Thank you.
You're welcome. Yeah, if you have questions, again, you can just join the session. There, it should be open and free. Or there should be no restrictions, but if you don't have questions, then that's also fine. Just a note on the repository. So, I mean, it's work in progress. It's not like it's all done and finished yet, but if you save the notebook and you just want to iteratively learn, so let's go to this website maybe again. With the time, I will of course go to a different branch maybe, but with the time there will be more in Colab versions of the things I basically reassigned and reworked, and yeah, and of course also then go through with other people in kind of a teaching setting on Friday afternoons if you're interested again, and then it will elaborate, but yeah, just save some link to this repository and then navigate through it, and you get hopefully maybe yeah, a good overview. But again, I mean, most of it you will find in other places, and every library has good tutorials on their documentation sites, and you don't need to really force to go here. But I mean, if I teach it, it's good that I also work a bit with my examples and make it here application specific as much as possible to health data sciences, which is probably not your interest, but yeah. All right. Any more questions? Otherwise, I would call it a day.